Okay, so this video is about doubling the angle at the bow again, but it's that tricky extra bit when the boat gets closest to the lighthouse and how we're going to figure that out. So let's take a look at a question that we're going to do. Here we go. A boat is travelling at 26 knots on a bearing of 120 degrees true. Okay, so our boat, doesn't matter where that boat is for now, but the boat is travelling at 120 degrees true. Set yourself up a north line. You don't have to do your north line super dark, just make sure it's there. Take one of these. And the boat's travelling at 120 degrees true. Okay, so I'm going to draw that line in. Our boat is travelling along that line. Make it a nice line, make a little arrow there. And that's happening at let's go back to our question. At 0600 they see a lighthouse at a bearing of 95 degrees true. Okay, so at 0600 they see a lighthouse at a bearing of 95 degrees true. Line that up with your north line. 95 is about there. Okay, there we go. Now this is a sight line, so I'm just going to put a dotted line in here. Okay, so labeling the angles, that was 120 degrees. This bit here is only 95 degrees. Sorry, I'm coming a bit closer on that. Okay, this bit's 120, this bit's 95. Which means that this bit, which is the angle at the bow, the boat's travelling this way and the angle at the bow comes over there, is 120 minus 95, that's 25. So the angle at the bow is 25 degrees. And you've got to calculate that, so make sure that you've got that bit. Next bit. At 7:15, the angle at the bow has doubled. Okay, so create a new line here. I'm going to try to make this image quite large. 7:15. So at 7:15, the angle at the bow has doubled. So for us, this is the first time that you set up your protractor with it not facing north, but instead facing along the angle of the boat. Now the angle at the bow before was 25. The angle at the bow here is going to be 50. So 10, 20, 30, 40, 50. Back to 310. Okay, and that's going to be another dotted line. Just make that dotted line a bit darker over here so you can see it properly. Done this well, nearly ran out of page, but not quite. That's the lighthouse. Make sure that you label that. Okay, so this line and this line should be of equal length. And we should know what that length is, because if I go back to my question, the boat is traveling at 26 knots, so speed, sorry, get my page back. Speed equals 26 knots, and it's been traveling for from 6 hours to 7:15. So time is equal to 1.25 hours. So we should be able to find the distance here. Distance equals speed times time equals 26 times 1.25. And I should be able to put that into a calculator. 26 times 1.25. Okay. So this length here is 32.5, which means that this length here is 32.5. That's important information. Now let's go back to our question. Okay, there are two distinct questions here. What is the closest this boat will get to the lighthouse? Now, if our boat's travelling past a lighthouse, hang on. get our screen back. If our boat is travelling past the lighthouse, there's my boat going past the lighthouse. The closest it will ever be is when it forms a right angle between its path and the lighthouse. So, it looks like it's going to be about there. Let's put a mark there. Now again, this is another sight line. That point there is closest to lighthouse. That's when it's going to be close to the lighthouse, when you create that right angle. Alright, the other angle you know, and should have already put it in there, is this angle here. You measured that angle, so you know that angle is 50 degrees. Now, try to narrow your view a little bit, just to this new right angle triangle. This one here. If you see this just as a right angle triangle, you can start applying trigonometry to it. Okay, so what I might do is just draw that triangle real quick, same triangle, just over here. Bam, 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 right angle triangle. This is a 50-degree angle, and that's 32.5. Now the first question in our first question in this asked us, what is the closest this boat will get to the lighthouse? Now, the closest is a distance, and it's this distance here. It's the distance between the boat at whatever time it gets closest and there. We can call this x. So, if I go back to my little triangle up the top, which is the same as this triangle down here, and I'm trying to find x, this is a trigonometry problem. I've got an angle, so theta is equal to 50. This is the longest side, and that's called the hypotenuse. So the hypotenuse is equal to 32.5. And I'm trying to find x, which is the side that is opposite the angle that I know. So that's the opposite. So opposite is equal to x. Now you'll remember your saw, car, toa. In this case, we know the hypotenuse and we want to know the opposite, so we have to use SOHCAHTOA, SOH, S-O-H. So sine theta equals opposite over hypotenuse. Sine 50 equals x over 32.5. And we can rearrange that. 32.5 times sine 50 equals x. Might just calculate that on my calculator. And that gives me a length of 24.8964. Let's just call it 24.90. Now, it's important to note that 32.5, if I get rid of my calculator, 32.5 was your distance in nautical miles. So this must also be a distance in nautical miles. That's a distance in nautical miles, so that must be a distance in nautical miles. So the answer to our first question here, what is the closest this boat will get to the lighthouse, is 24.90. Oops. Is 24.90. Okay, so that's step one. Now, you might get asked that question, but you might also not get asked that question at all. You might get asked a question like this: when will the boat be closest to the lighthouse? Now, if that's the case, it's still the same kind of question, really. What you need to do is find this length, because this is the distance that it travels from here to here before it becomes the closest. So the length is going to be y. Now let's look at our diagram at the top again. I can forget about x. This time I'm going to solve for y. And I know the hypotenuse, I know the angle, and this time I want to know the adjacent. So this is going to be a cosine question. Cos theta equals adjacent over hypotenuse, which equals cos 50 y over 32.5. And now this time it's 32.5 times cos 50 equals y. Okay, let's go back to our calculator. Oops. All right. Sorry, fellas, that calculator works backwards. Y is equal to 20.89. Now again, 20.89 nautical miles. Okay, that's the distance you travel. The very last step in that question, because remember that question isn't asking how far do you travel until you reach it. It says what time. So we're going to have to do like a speed, distance, time question. Time equals distance over speed. The distance we're traveling is 20.89. The speed that we're traveling at is 26 knots. Now if we put that into our calculator, 20.89 divided by 26, we get 0.8034. Now that 0.8034 is the number of hours it takes. So it's going to take 0.8034 hours to get from here to here. Now in minutes, if I multiply that by 60, I'll know how many minutes that is. Let's just round it and say 48 minutes. But then I need to say what time did I get there? What we're saying is it takes 48 minutes to travel from here to here, which means that I will get there at 7:15 plus 48 minutes, which will be 8:03. Okay, big long question here, guys. Important to understand that if you do get asked a question like this, make sure you know whether you're being asked this or you're being asked this and time. Make sure that you know what they're asking you for. And then it's really a matter of drawing up your triangle neatly and then figuring out whether it's sine, cosine that you're working with. Alright, longest video ever. Thanks, guys.